Hi everyone, this is Poornima Mahalingam, working as an assistant professor in the Department of Tripling. In this video lecture series, next we are going to discuss about Zener diode and its characteristics. Come, let's go into the topic. So before going to topic, what is Zener diode? We can see the basic definitions of Zener diode. So Zener diode is a special diode that enables the current to flow not only from positive terminal of an anode to the negative terminal of the cathode, but in the opposite directions. So previously we have seen the PN junction diode. It is an unidirectional device, but in Zener diode is in both bidirectional device. It flows from positive to negative and negative to positive. Okay. So in this, here the doping of the Zener diode is more than the conventional diode. So the depletion part has less error. So the doping is higher than the normal conventional diodes. So the general diode does not operate in the reverse diode conditions, reverse bias condition, but the Zener diode are especially manufactured for the reverse bias conditions. Here the main thing is the reverse bias conditions. The main thing is this operates in the reverse bias condition. Here the picture, this is what Zener diode. Here, this is what Zener diode, and this is the symbol. This is an anode. This is what cathode, anode, cathode. Then the Zener diode is most used type of electronic devices like computer, laptops, and the basic components. So it is used for the power stabilizer, that is a voltage regulators, and it is also used for electrostatic discharges, and the current flow suddenly among the charging point by shorts or breakdown of the insulator. It's the ESD, that is electrostatic discharges. Here we can see the how it appearance and how the symbol and backward flows backwards from cathode to anode. Okay, here the Zener breakdown voltage. So here coming to the constructions part, and the same as an PN junction diode is designed to operate in a reverse bias conditions. Here the two type of breakdown we can see, the one is avalanche breakdown, next one is Zener breakdown. The avalanche breakdowns occurs in both the rectifier and the diodes and significantly high reverse voltage. But Zener breakdown occurs in the Zener diode alone. Zener diode breakdown occurs in the Zener diode alone, and the Zener diode is heavily doped to reduce the breakdown voltage. So to reduce the reverse breakdown voltage, here the diode is heavily doped, and the diode characteristics are determined by the doping process. Here the Zener diode is commercially available with the voltage of 1.8 volt to 200 voltage. So it is applied for commercial available based on the application. The available voltage is 1.8 to 200 voltages. Here the Zener diode forward bias characteristics. Here we have forward bias, and is a normal, it acts like a normal diode when the positive is connected with anode and the negative is connected with cathode. Okay, here the positive is connected with anode, negative is cathode. And here in the reverse bias, positive is connected with cathode, and in negative is connected with anode. Okay, this is what connections and the characteristics. The characteristic source, the forward bias is act like a normal PN junction diode. So then this act like a normal PN junction diode. But in reverse bias conditions, what happens? The breakdown voltages occurs. Here, in reverse bias conditions, the current between 0 volt to 0 voltage, and the current is able to flow when the voltage reaches through the breakdown. When the voltage reaches the breakdown, the current flows through it. When this voltage reaches to the breakdown, that is known as avalanche breakdown or Zener breakdown, the voltage current get increases. Here, a small MCQ or activity. So the level of doping of Zener diode is the level of doping is heavily doped. Here breakdown, we have two types of breakdown. One is avalanche, next one is Zener breakdown. So avalanche breakdown occurs normally in both the diodes, in both the PN junction diode and Zener diode. But Zener breakdown occurs. Here see the breakdowns, general breakdowns occurs. But Zener diode occurs in the Zener diode. Zener breakdown occurs in the Zener diode based on highly doped, because of the highly doped. Because of highly doped condition, this Zener diode occurs. So here we can see the characteristics of Zener diode. Forward bias as it is normal PN junction normal PN junction diode, and reverse bias. Here, this is the Zener breakdown. Here this occurs when it is heavily doped. When it is heavily doped, and then avalanche breakdown, this occurs in normal PN junction diode. That's the difference between here. The voltage breakdown voltage gets increases, because of that the system damages gets reduced. This is Zener effect, and it's electric failures. And here we are seeing some of the advantages, and efficiency is very high and is available in small size and it is less expensive diodes, and applications also used in voltage regulators, the switching purpose, and we have so many applications. And the Zener diode is mostly used in yes, it is mostly used in voltage regulators. Here we can see the small animation video.
Hi guys, in this lesson I will explain the working principle of the Zener diode, which is used for voltage stabilization in electronic circuits.
Anode, cathode. Anode is connected with the positive, cathode is connected with the negative. Here the normally supplies, here that's become a normal diode current flow, anode to anode, cathode to cathode. What happens?
Connection to the circuit. When connected in reverse, it remains
so after break the voltage begins the current flows. We know all the parts this act as a normal. Here was in a diodes. Here we can see the Zener diodes.
Reference voltage for protection purposes. So the working logic, I built a circuit where the resistor and two Zener diodes are connected.
So the input is 9 volt. What happens? 3.3 volt. We can see the output 3.3 volts. What is because this whole output is 3.3. We can see 3.3, and here the total is 9 voltage. 5 still because of 8 volt. If the input is 12 volt, but still the voltage is 9 voltages because it regulates the voltage. Here there is a resistor with the resistor. It is protected against the resistor.
Here you can see output from the total break.
So these are the sum of the outputs. So 10 voltages. So based on application, we can get the different voltages.
The Zener diode is as here. In the case of forward polarity, starts to pass current.
Here you can see that. So 5, finally we are getting output. So we increasing the powers. Zener diode connecting in series and parallel. See, as a voltage clippers, clampers, applications. The Zener diode voltage regulators and application samples. So in this topic, we are seeing about what is Zener diode and how it is works and where it is used, and applications, advantages and disadvantages. With some other topic we can see in the next series. Thank you so much.